that again. All right. So what we'll do is we'll do the other eigenvector, which was what? -4. So we're going to repeat this process again. Okay, use lambda 2 minus 4. So we start off with our 1 minus. I won't always do these, I'll drop lines out in the future, but it's important that we get this process right. Okay, it's important that we get this correct, because I don't want you to come away underprepared for what we're going to do. And the one that we're using is lambda 2. So what we're going to do is now do the transformation. So we're going to do 1 minus -4, 6, 5, 2 minus -4, 0, 0. So that's the dropping of the equation form now. We're augmenting. So we're going to the other form. So I can just do our equivalents. So 1 minus -4 is 1 plus 4. And I'm going to drop the brackets. And 2 minus -4 is 2 plus 4. Okay, and we'll get a similar scenario. So our row operations, we can do row 2 is going to become row 2 minus row 1. So row 1's not changing. Five minus 5 is 0. 6 minus 6 is 0. Aha! We got it. We got the infinite solutions that we expected. So that's the algebraic result that matches the infinite solutions version. Okay, so infinite solutions version. So we assign x2 is a free variable. Okay, and we can express everything else. So if we do a rebuild here, we've got 5x1, because remember that's the x1 column, x2 and so on and so forth. 5x1 plus 6x2 is equal to 0. And we said x2 is a free variable. So x1 can be expressed by rearranging. x1 will be equal to, we minus 6x2 and put it on that side, and divide by 5. So we've now got this pair. Okay, so we've got x1. So I think I made the distinction here. Not yet. So x1, x2 are our eigenvectors. We've established that they have values, and x1 is expressed in terms of x2, and x2. x2 can be brought out. Minus 6 on 5 and 1. Now at this point here, there's a couple of things that we can do. We can multiply this by some number just to firm this up. Okay, so I'm going to multiply this by 5. So each term will get multiplied by 5. So this will result in x2. Now the 5's will cancel up the top, and 5 1's are 5. So that's the equivalent whole number vector. Okay, so this is where we now do our signal interpretation. This is like being in, this is our intelligence. Okay, so we've got v is equal to minus 6, 5. So what we should get is our transformation matrix multiplied by this vector that we've just found, which should do, so that's our AX equals, now row down column. Now with the row down columns, I'll just do it, just to reinforce the idea, because I think Trish, you asked me about this. So row down column will be 1 times minus 6 plus 6 times 5, and change that to row down column. So that will be 5 times minus 6, sum of products, plus 2 times 5. Okay, so we've got minus 6 plus, sorry, I'm just being a bit lazy there. So minus 30 plus 10. So the bottom number will be minus 20. And the top number will be minus 6 minus 30. Is that right? Minus 6 plus 30. One times minus 6 plus 6 times 5. Get it right, mister. So 30 minus 6 is 24. Okay, so that should be, what's a common factor that we had? Where's our vector? Minus 6, 5. Can we write our vector as minus 6, 5 multiplied by some lambda minus 4 equals lambda x. Okay, so we've been able to establish what the vector is. So again, minus 6, 5, that's all right, isn't it? Minus 4, yep. Minus 6, 5. So if we look at this on this kind of thing, minus 6, 5. And it gets transformed to 24 minus 20 way down here. So that's a reversal. So it's a reversal. That's our original V, and that's our transform V. But it's still on the span, so it's the result of an eigenvector, eigenvalue idea. So eigenvectors and their eigenvalues. Hopefully that concept is absolutely solid now, and you can spend some time cogitating on these notes and think, okay, we know what to expect in terms of the algebra. So can we do it for 3D? Okay, and that's going to be the next step. Okay, so last week I pulled out some transformation vector and put it there. This week I've just done the 2 versions. Okay, now if you want to, I can give you a mini tutor homework if you like. I don't know, you're pretty busy. What do you want? I'll leave you alone. Do you want the practice, or do you want me to do it? Do you want the practice, or do you want me to leave you alone? Is just studying this going to be enough? I'll make it optional. Let's do it this way. I don't need to see it, guys. Okay, if you've got a question, I'm happy to do it. Just basically following the same procedures. Okay, if you can generate the eigenvectors and eigenvalues from what we've done there, that'd be wonderful. And to make it fair, what I'll do is let's jump in. You don't need to do the whole thing. Don't forget to augment. The next step will be to augment. So we do the det thing, augment, and you just follow on it, almost line for line. Okay, and if you wanted to do that, you need to discover the eigenvalues and then their corresponding eigenvectors, and then try and understand what the geometry is, the way that we have here. Okay, with these two eigenvectors and eigenvalues, remembering all along that this process here of transforming these, so that's an optional tute for you. Okay, completely optional. All right. So just remembering that I'll trawl. I've had a look at any submissions you've made, and I'll trawl through those over StuVac and get some feedback to you over StuVac. So I haven't forgotten that. All right. So I think rather than jump into the next one, because we've still got 2 full weeks to go before we do have a break. So I'm thinking that I might leave the 3x until next week. What do you say? You happy with that? Yeah, I'll leave the 3x. So I'll give you what we'll next week. All right, we'll do it that way. So, and the operations and the skills that you learn are really worthwhile following up with in your future. The hard part in New South Wales is that it's not part of the curriculum for high school, and I really hate that because it's really an important part of what you'll do. So that's next week. We'll have a look at that one next week. We'll do all the row operations. We'll jump in. We'll find the eigenvectors. There'll be 3, obviously. We'll find an eigenvalue, and we'll do all the drudgery of getting that out. Okay, and that sets us on a very good path for us to come to terms with what eigenvectors and eigenvalues and how they contribute to systems of TVs. All right. Okay, is there any questions? Is there anything else? Because it's about 8 o'clock, so I think what I'll do, I'll give you another early mark because you've been so good.
Can I just quickly ask a question?
I'm here for you. I'm here for you.
So there's a so you know how you factorize the -4 out. Can you factorize the 4? Like, is there a reason why it's -4 and not +4?
Here?
Like the very yeah.
No, you could take the 4 out, but wasn't the characteristic equation, didn't it give us a -4? Okay, so the eigenvalue was -4. So you're quite right. There's no reason why, if I factorise the 4, I'd have to have 6 there and -5 there. Now that 6 minus 5 is a different vector. That's a different vector. Okay? So when we're doing algebraic steps we need to be careful, because that is the eigenvalue, and that eigenvector is the one that we found. That's a match, isn't it? They're a match. So yes, you can, but it's a different solution set. It's a different eigenvalue. So while it's practicable that you can do that, you've got to find the match. Okay, we've got to find the match, because that's the vector. We discovered that vector. Remember, we didn't know that vector. That vector was x1 and x2. But doing all of this fancy pants stuff up here gave us this vector. Okay, so we actually found the vector that we were using in our transformation, which was the whole goal.
Yep.
Yeah?
Yep.
So if you do the factorizing, and this is the great danger of matrices, right? This is the great, and yeah, it's the great danger of matrices. So when you do that, yeah, so we started out with -4. So the assumption would be that the variable that you're going to take out would be the one that was a match from what you used. Yeah? Is that all right? Okay. Now, I had something else on my mind, but I think I was working on something. I mean, I don't want to keep you tonight, but, you know, there's so many things that I pick up that might be useful. Do you guys know how to do something like this? Is that something that you guys are familiar with? Or it could even be 7 plus x. It wouldn't matter what it was, but the concept. So if I do that kind of thing, you can immediately recognize it as 1 over x and 2. So whatever that point there is, that's the solution set. Everything to the right of that, above that line, is the solution set. What's that value? So basically, all right, so there's a lot of conjecture about how to do these. If you watch Eddie Wu's video on this, I got confused. And I respect him, right? One of the other methods is that you can multiply through by a square. What's the issue here? What's the concept? Sorry, I don't. Do you mind me doing this just for 5 minutes? And then we'll go. Okay, so what's the concept here? The concept is that this inequality needs to ring some bells. If you multiply across the inequality by a negative, it reverses that inequality. That's the golden rule. Okay? So if that x is negative x, that will change this to this one. If x is negative. And I will say that by saying less than 0. That's the same as saying x is negative. Okay? Now, if it's positive, if x is positive, which is the way you would say that, x is positive, and you've got to explicitly teach that to students, then you would maintain your multiplication. Okay? So how do we take the cases into account of positive and negative? Well, one way to do it is to multiply by the square. Because if it's a square, then it's always going to be positive, safe. Now, Eddie Wu makes a good point that when you generate the quadratic and you get away from the graph, the interpretation of the values is important. Okay, but I just want to simplify this, because these are something you can go away and look at this now. This is really just another one of those annoying know-how things I'm going to give you. Alright, so if I do this, I'll get 7 plus x is greater than or equal to 2x plus 2. So I've multiplied through by x plus 2. Then I can go 7 plus x 2x plus 4, and then I can put them together, so I can subtract the x and subtract the 7 even, so I get 0 is greater than or equal to x minus 3 or something like that. Or I could leave the 3 over there, and so 3 would be greater than or equal to x. So on a number line, this is telling me that x is greater, 3 is greater than x. So if I've got a 0 and a 3, so if I turn that around, that might be easy to interpret. I don't know why I did that. X is 3. So x is less than or equal to 3. So it's inclusive, so you've got to colour it in and go off to infinity. Now that's not the answer, right? Because we have assumed something. So what we do is we intersect that with x plus 2 is positive. So that means that x is greater than minus 2. Okay, so if we come down here, it's the intersection of x is greater than, wait a minute, did it again, x is greater than minus 2. And so we go to turn that around, minus 2 is less than x. That's fair enough, isn't it? So then I go to minus 2, and it's a circle this time. It's not a colour it in one, it's a circle. Just move him off there. And what are we saying? Minus 2 is less than x, so minus 2, it goes like that. X is greater than minus 2. The intersection is that interval where they cross over. So we've got minus 2 and 3. That's the interval. You can check all that yourselves. So I just wanted to do that because there are things in the curriculum that get you, are gotchas. And this is a great gotcha. I had a colleague who I told you that I looked up to. I was a bit annoyed that he did this, but we were seeking a maths teacher. This was over a decade ago, so it's not relevant now. But and he gave him a problem like this. He gave the teacher a problem like this in the interview. In the interview. And he said he couldn't really do it. And I said, okay, but you didn't base your decision on that alone. Oh, no, there were other things. But I thought, oh, and he's normally such a just dude, you know? And I thought, man, seriously? This is one of the most contentious things, dealing with inequalities. Anyway, that's another one of those. Hey, Jason, can you help me with that? Okay. In the curriculum know-how bucket. All right, let's leave it there. And I did test it to see if it was positive, and assumed that it was positive. It took the intersection, and so you can put those on technology as well. I don't know if you've ever thought about doing that, but you can do, what did I say? X plus 7 plus X, was it? Oh, wait a minute. What am I doing? 7 plus X. E. Divided by X plus 2, was it? Yeah, X plus 2. Sorry. And greater than? I think it's equal to greater than, isn't it? And what did I say it was? 2. Let's see what that looks like. Yeah, that's what I wanted. So there's your 2, and there's your greater than, and so same thing. Ta-da! Okay. So just around intervals, the reason that I'm raising it with you is because I don't get many opportunities to talk to you about analysis. I have done as much as I could in the early parts of this course, this subject, but this is the beginning of analysis. You want to know what analysis is? Pull this up. Okay, and this is something that you can develop. Okay. Anyway, that's just a little bit for you to consider in the many things that you're considering. I wanted to give you that because you probably won't get taught that. All right, let's leave it there. Okay, and I will see you next time. All right. So thanks very much for coming along, guys. I appreciate it.
All right. Thanks, Jason.
Thank you.
Have a good week.
Okay.
Can I just be annoying for a sec?
Of course. You're never
So,
annoying to
you
me.
know-
It's fine.
So that inequality question, it was such a coincidence because my sister asked me yesterday, and I know that you can times it by the denominator and you can square it.
Yeah, that's what I said. Yeah, let's do it.
So
Let's
so
do
when
it.
you do it, like you get I'm just trying to work out why does it work.
Okay, so the thing about the inequalities, right, is there's a rule. If you go across there by a negative, if you times by a negative, right, reverse the sign. Okay? Now, if you multiply by the square of the denominator, both sides, have you multiplied by a negative? And why? And the answer is, no, you haven't, because anything that gets squared is a positive.
Yep.
Okay? So in this case here, if we do that, that'll cancel, and we'll be left with x plus 2. Now here's the dilemma. You've got to be careful doing this. A lot of mistakes are made by students in doing this. Okay? Now let's expand.
I can't see the screen. Sorry, I can't see the screen.
Oh, I've got to share it. Sorry, my bad. So there you go. All right. So with this one, so let's expand this. So just cross that out. You reverse the sign. Anything that's negative is positive. Okay, so that's why they do it as a technique. So x squared plus 2 times x times 2 is 4x plus 4. And so we'll get x 7x plus x squared plus 14 plus 2x is greater than or equal to 2x squared plus 8x. Now I'm doing the expansion, plus 8, and getting them all on the same side. So we'll put a 0 here, we'll just wing it. 2x squared minus x squared is x squared. 8x minus 7x is x, but minus 2x is minus x. And 8 minus 14 is negative 6. Okay, so that's the first problem. The first problem is you get this horrible looking thing. Okay, now you've got to understand that quadratic. And so what this, now in a way it's changed the question. You can't think geometrically now because you've gone away from this thing. This is a hyperbola. No matter what you do, this is one of these. Okay, it's not a quadratic. This thing here is so if we just quickly solve this, so what have we got? X.
I think it's minus 3 plus 2, maybe.
That looks right. Okay, and so what we've got is therefore x is equal to 3 and minus 2 and minus 2. Okay, so we want above 0, but this is the wrong interpretation. Okay, now what we've got to do is take these away and go back to the original thing here and say what's going to work. Minus 2 is not going to work. X minus 2 is going to give you a denominator of 0. And you can't have that. So how you interpret the next steps now is very important. So all it means is that you need to have a bit of a gist of what the graph looks like. Because what you're going to say is the minus 2 is not part of it. So there's your -2. You're going to put a circle on it. The 3, does the 3 work? Well, you go and put the 3 in. 3 plus 2 is 5, that's a tick. 7 plus 3 is 10. 10 on 5 is 2. Greater than or equal to 2, that's a tick. I'm just looking at the original. Okay? So that's included. So you've got to colour it in. And that's the interval. And that's exactly what we did before. But that's a big skill. Okay, that's a big skill. Test these. And students, there are two sources of mistakes. One source of mistake is the unpacking of the quadratic, and I skipped quite a few lines to get to this line. And then making sure that you understood what was going on here, that this wasn't what you were looking to do. It was testing them to get your interval. Okay, so that's very commonly taught in schools. Multiply by the denominator squared. It's a very common thing. This one here is a bit of an old man's thing. Right? It's a bit of a crafty way of dealing with it. Now they've got another one that they talk about, which is, I forget the name they use when they apply it. But Eddie does an analysis of the graph. The thing I don't like about that technique is that's a fairly complicated quotient to express. If it's a simple quotient, it's fair enough, but it depends on. So as a teacher, what you do, you wouldn't give that quotient. I just pulled that out of my head. You would give a quotient that the students had some hope in answering. Okay, so you would do something where there was